All right, happy Monday. So the focus for this week, we get back into some triangle trigonometry. Now let's remember how everything worked before. We have a right triangle. If I give you an angle, we've got a right angle on one side. Can we find the others? Now here we know that there's 180 degrees in a triangle, so if that's 40 degrees, that's 90 degrees. I'll put that in there, 40 degrees, 90 degrees. Of course, that has to be 50 degrees because there's 180 degrees in a triangle. Nice and easy. We know two angles, we can always subtract from 180 to get the other. Now, notation. We've got uppercase A. Lowercase letters are our side lengths. Uppercase letters are our angles. The sides and the angles are opposite. I'm going to use the same letters to correspond to those sides. So uppercase A is the angle A. Lowercase a is the side A. So we've got this side is going to be 8 units long. We want to find the missing sides. Well, it's a matter of fact, it's just looking at, okay, we want B. Well, looking at what we're given, angle A, we've got the opposite side. We're trying to find the adjacent side. Or we could say angle B, we want to find the opposite side, we've got the adjacent side. SOHCAHTOA, that's going to be the tangent angle. So we'll set up tangent of 40 degrees, and it's a good idea to use the given information because it's an exact value. Now 50 degrees is an exact value. That's okay. If we end up rounding at some point, always try to go back and use the original information. So tangent of 40 degrees, opposite over adjacent, we're going to say we've got 8 over side B. We know how to do that. We'll cross multiply. B is 8 over tangent of 40 degrees. We'll plug that into the calculator. Now here, I'm in radian mode. I'm in degrees here. Make certain that we go back and use the correct mode. Be careful with that. We're going to be working with our triangles once again. So triangles, typically we are in degree mode. Side B, we've got 8 divided by tangent of 40. That was 409. Let's try that again. B is about 9.53. We've got one side. Let's find the remaining. Now I could Pythagorean theorem, but in doing so, I'm using a given side, a side that we just rounded a little bit. Now, rounding error, it's going to be off a little bit. I'm going to try to use the given information. So I'm going to use angle A, 40 degrees. I'm going to use side A. Well, that's opposite. That's hypotenuse. SOHCAHTOA. That's a sine angle. So I'll plug in. We've got sine of 40 degrees equals 8 over C. Do the same exact thing. C equals 8 over sine 40. And we've got side C, 12.45. Hooray. Nice and easy. But what if we don't have a right triangle? Now, two angles and a side. Same thing as before. We've got 28.7, 102.3. Together, that gets us 131 degrees. Well, we can figure out the rest. That's going to be, what, 49 degrees? Because we've got 180 degrees in triangle. We do not have a right triangle here. Now, listing the sides, I'm just going to write everything in. We've got 27.4. I've got 102.3 degrees, 28.7 degrees, and 49 degrees. Uh-oh. Well, what we always did, find a right triangle. Let's drop an altitude through there. Now we've got two right triangles. But I've got this sign. Oh well, let's see what happens. I'm going to give x to be portion of that side length. I'm going to put, this is going to be 27.4 minus x is that side length. And so we can start finding pieces. Well, we're writing equations. We're going to have sine of 49, let's restart that. Tangent of 49 degrees is going to be h over x. We're going to have tangent of, let's just scrap this whole idea. I don't want to do that example. Start fresh. A, B, C. Let's say we've got 8 is 30 degrees. B is 100 degrees. That leaves us C. There's A, B, C. 30 degrees, 100 degrees. Easy to find the missing side angle measure there. We've got 30, 100. That's going to be 50 degrees. Let's say A is a measure of, just to make it simple, 10. B and C. Same idea. I didn't want to do the one where we've got multiple angles, multiple side lengths, so start off easier. 50 degrees. If we've got one side length, now here we have an angle side triangle. Don't have a right triangle? Make a right triangle. I'm going to drop down that altitude. Call that H. We still have those two components. I'm going to find C first, and then I will find B. When I see sine of 50 degrees, it's going to be opposite over hypotenuse. Well, side length of 8 now becomes the hypotenuse. So we've got H over 8. I can solve H equals 8 sine 50. We can get a value for that. Over in the right triangle, we could come up and say sine of 30 degrees equals H over C. Well, we know H from this past statement, so here we're going to have H equals C times sine 30 degrees. We can substitute in for H, so we've got 8 sine 50 equals C sine 30. And when we divide, side C, 8 sine 50 divided by sine of 30 degrees. We can find side C. We've got 12.26. Finding the remaining side. Well, we can do the same idea, but I'm going to use, let's see, that's 30 degrees. That's going to be 60 degrees. That's 50 degrees. That's, nope, that's the one I had written occasionally. 70 degrees. Apparently today when I'm in for surgery, they better do a head transplant. So 100 degrees, I was right the first time. 60 degrees, because that's a right angle. Okay, that's 50. That's 90. That's going to be 40 degrees. Try this again. Sine of 60 degrees. We know side length C. Sine of 60 degrees equals opposite over hypotenuse. That's going to be, I'm going to call it B sub 2. Let's adjust the paper a little bit. B sub 2. So sine of 60 degrees is B sub 2 over 12.26. That's our side C. We can solve for B sub 2. 12.26 multiplied by sine of 60 degrees equals B sub 2. All right. B sub 1. Well, if we've got 40 degrees up there, we've got sine of 40 degrees equals B1 over 8, side A. B1 is 8 sine 40. B is the sum of B1 plus B2. Okay, let's do all that together. 12.26 multiplied by sine of 60 plus 8 sine 40. We've got 15.76. Found all three sides. Well, if we were to do another example, where we've got two angles on a given side, we'd do the exact same thing. Every single time we'd find the altitude, we'd find the parts. Well, we could keep on rewriting altitudes and writing altitudes. We would find that we're doing the same thing every single time. So let's see if we can automate it. Given, so we're going to say, do the same thing for any triangle. So good enough. given two angles on one side. So given A, B, and A, how can we find the rest? Well, angle C is always going to be 180 degrees minus A minus B. We can always find the third angle by subtraction. Now what we would do every single time, let's say we have AB, we can always find C, we would constantly drop that altitude, find that part first. We notice that sine of C is going to be h over A. We notice that sine of A is going to be h over C. By some rewriting here, we're going to have C over sine of A. We have C sine of A equals H. We have A sine of C equals H. Therefore, the two things are equal to each other. A sine C equals C sine A. Now, by combining, A divided by the sine of A equals C over the sine of C. Just by relabeling things, that's C, and that's B now. We would also have the same statement, that B over sine of B would also be equal to that H. Or we could drop another altitude going in a different direction and see the exact same thing. What we have here is a relationship that does not need a right triangle. Since we are doing the same thing each time, we've got this statement, that A over sine A equals B over sine B equals C over sine C. We call this, let's get rid of the extra, law of sines. This works for any angle, side, angle triangle. No right triangle is necessary. The idea is we take into account everything that we're doing repeatedly, and we just automate it. There goes the calculator. Let's do an example. So we have two sides, two angles, given side. In this case, always going to start off, draw a triangle. You have a description of something, draw a triangle. At least label out what we have. A, B, C. We have 43 degrees. We have 98 degrees. Together, that is 141 degrees. That means that this has to be 39 degrees. We've got A, B, 22. By the law of sines, we're going to have A over the sine of 43 degrees equals B, whatever it is, over the sine of 98 degrees, equals C, in this case, 22 over the sine of 39 degrees. Pick two ratios. We have one unknown statement between the two of them. We'll solve for that part. If I'm solving for B, I've got 22 sine 98 degrees over sine of 39. $34.62. And we'll solve for A. I'll take the other two statements. We have A equals 22 sine 43 degrees, or sine of 39 degrees. And we've got 23.84. Done. There's our law of sines. Given any triangle, no right angle needed, no more SOHCAHTOA, because we automate it, we connect all the ideas. The ratio between a side length and the sine of the opposite angle is constant all the way through. There's our law of sines. Have fun.